Well, hello and welcome to Math Blossoms, where growing in mathematics is natural. I'm the teacher, Miss G, and for today's topic, we are learning how to solve one-step equations and just a little bit of terminology about the different parts of equations that we're going to study in this series of how to solve equations. So this is video number 1. The next video after this would be the two-step equation video, and then after that would be multi-step and so forth. All right, let's get started on today's lesson. First of all, let's go over a little bit of this vocabulary. We have expression, a mathematical statement that contains at least two numbers, variables, or both, and at least one operation. The difference between an expression and an equation really is the equal symbol. An equation is a mathematical sentence that has two equal sides separated by an equal sign. Term a single expression in an algebraic expression that can be a number, a variable, or multiple variables multiplied together. So basically the difference between an expression and an equation is that equal symbol. If you have an equal symbol in it, it is not a mathematical expression, it is a mathematical equation. Coefficient is the number or symbol that multiplies another number or symbol, such as a mathematical variable. So in the picture below, you can see that the coefficient in this equation is the 7. It is a number that's being multiplied times our variable. And the variable is a symbol that's often a letter that represents a quantity that is unknown. Usually it's what we're solving for. A lot of times we use X, but it doesn't have to be X. It can be any letter of the alphabet. Constants are numbers or symbol that has a fixed value and does not change in an expression. For instance, the 2 and the 9 are both constants because they are just standalone numbers that don't have a variable sitting right next to it. And also terms, that's another definition that we probably should have added to this, but terms are the different parts of the expression or the equation. For instance, the 7x is a term, the 2 is a term, and the 9 is a term. They're often separated by operators like plus, minus, divide, multiply, or symbols like equals or inequality symbols like greater than, less than. So in this particular equation, we have three different terms. We have one coefficient, we have one variable, and two constants. And there's one expression in this equation, and it's just the 7x plus 2 part of the equation. So hopefully that will help you kind of understand the different vocabulary terms of the different parts of the equation. We'll go over it just a little bit on each video, but when I start talking about coefficients and constants and all these things, hopefully this will clear up what I'm speaking about. Also, oops, it's not going, there we go. The question we're trying to ask ourselves in this entire equation series is, how do I solve equations? Well, we're going to start off with one step. We're going to move up to two-step, then multi-step, and then variables on both sides. And then we have these special cases type equations and so forth. But we use a device called Don't Call Me After Midnight. It's just a way to remember the order in which we should look for things in our equation. And then often we do those steps from top to bottom. Like we would start at the D, then move on to C, then move on to M, A, and M. For solving any equations, we do something called inverse operations. Inverse is just the mathematical word for opposite. So when we're looking at different things in our equation, we're looking for operators like plus, minus, multiply, divide, and then oftentimes we have to do the opposite of that operator in order to isolate our variable. The order or steps to solving equations can be remembered with the phrase, "Don't call me after midnight." For one-step equations, we will only need to use one of the last two steps. Like I said, normally in a multi-step equation, you're going to start at D and work your way down. However, for one-step equations, we only have one step to do, and it's either going to be add, subtract, multiply, or divide. Let's try some. Okay, so we're going to show our work on this. Let me get a pen out here. All right, so we'll start with red. Okay, so the first thing you should ask yourself is, what operation is happening to my variable? The variable is x in this equation, and the operation that's happening to it is we're adding a 7. It's plus 7, right? So we have to think about what the inverse or opposite of addition is, and that would be subtraction. So we're going to subtract the same number that is being added, and that will make that 0 out, which is what we want because our goal is to get x by itself, right? So now we have x on the left side of the equation by itself because we canceled out the 7. But because it's an equation, we have to do the same thing on the left and right sides of the equal sign, or else our equation's not equal anymore. It's just like a balance scale. If you put 10 pounds on one side of the scale, you're going to have to put another 10 pounds on the other side of the scale, or else it's not going to balance out, right? Well, we're subtracting 7 on the left side, so now we need to subtract 7 on the right side. And when I do that, I'm going to get a 3. So my answer to this equation is x equals 3. Let's try a different one. All right. Whoops. Why is it not working? We have to get it off of the... Oh, I'm malfunctioning. There we go. I think when my pen's up, it won't work or something. Okay, let's change colors. Okay. Now we have x minus 3. So, of course, we're going to look at that minus and think, well, what's the opposite or inverse of subtracting a 3? That would be adding a 3. And remember, we're looking at the side with our variable to determine what operator is happening to the variable. And then, of course, we need to do that same operation on the other side of the equation. And 7 plus 3 is 10. So our equation is now solved. X equals 10. I don't know why it keeps doing that. There we go. I guess I have to hit it like 3 times or something. Okay, now we need to change colors again. Now this one is multiply. Whenever you see a coefficient right there next to the x, that's a number being multiplied next to the variable. If it's being multiplied, this means 2 times x, then we have to divide to cancel that out. Now in this case, it's not going to create a 0, but that's a good thing because we don't want a 0x. We want 1x. There is an invisible 1 in place in front of that x. A lot of times mathematicians do not like to use ones. They don't like to write them out. So if there's 1x just sitting there, then you know it's 1x. If there's 2x's sitting there, then it would look like that and have 2 x's. And then if there's 3x and 4x and so forth, there would be that number in front of the x. So of course we divide on both sides, and 2 divided by 2 is 1x. And like I said, there is a 1 there, but we're not going to use that 1 because in math, we don't typically write a 1 that's not needed. Like we know there's a 1 there because there's 1x sitting there. And our equation is now solved because 8 divided by 2 is also 4. All right, we got one more. Let's see, and then we'll go move on to some of the ones with fractions. Now this one, what color have I not used? Purple. Here we go. This one's x divided by 4. Divided by 4. So to get that to cancel out, we're going to multiply. That's the inverse of division is multiplying. And when you multiply the number in your denominator times that same number, it will cancel both of those out, and then you're left with just the x. And then on the right side of my equation, if I multiply that times 4, I'm going to end up with x equals 8. Now, if you look at all these one-step equations, you can see that here the inverse of add was subtract. Here the inverse of subtract was add. Here the inverse of multiply was divide. And here the inverse of division is multiplying. And that's basically how you do it. Now, you will have some moments when don't know why it takes so long for this thing to switch. Oh, I see what I'm doing. Okay, you will have some that have fractions in it, so I'm just going to go ahead and pull all these up. And we're going to solve these the same way we did just the other ones, but this time we have fractions and decimals instead of just whole number integers. So this is x plus 1/2. So again, the operation is a plus, so we need to subtract. So let me go back to my pens here. And this time we're subtracting 1/2 from 1/2, and that's going to zero out. And when I subtract 1/2 from 10, I'm going to get 9.5 or 9.5. You can type that in the Desmos if you like to get your answer as well. Now this one is x minus 1/4. So that means we're going to do the opposite of 1/4, which is to, the opposite of subtraction, which is to add 1/4. And of course, that's going to zero out. And then because when you have a negative and a positive, they zero out. And even though that's a minus, the minus is the same as a plus negative. So remember, minus is, when you subtract any number, you're really adding the opposite sign of that number. So if that was confusing you, just think of it that way. You can think of the symbol in front of that, that number or that constant. You can think of that as its sign when you're combining like terms a lot of times. And when I add 1/4 to this 7 over here, I'm going to get 7 1/4. Whoops. So I did not, hang on, this one's x equals 7 1/4, or 7.25 if you wanted to put it in decimal form. Over here, though, we have x equals 9.5. I forgot to write out my answer. Now, at any time, you can substitute these values back into your variable to check to see if you're correct. Maybe we'll do that on this third one here. Let's see here. We've got x minus 0.5. So since that's a minus, we're going to add, which is the inverse or opposite of subtraction. We're adding a 0.5 to that, and a negative and a positive cancel out. And then when we add a 0.5 to this one, we get 8.5. So x is 8.5. Now, you can substitute this back in and see if you are correct. For instance, if I wanted to plug this 8.5 in place of that x in my original equation, it would be 8.5 minus 0.5. And if that equals 8, then I know that I'm correct. And it sure does equal 8. So at any time you can, once you find your answer, if you have time, you can substitute that answer back in place of your variable, work it out, and if you get 2 equal numbers, then you know you're correct. If you don't get 2 equal numbers at the end, then something may be off a little bit. All right, we have one more, and that is this one down here. We have x divided by 0.4, and we are going to multiply to get rid of that division, because multiply is the inverse of division. And again, when you multiply a number that's in the denominator by that same number, you're going to cancel that out and just leave yourself with 1x. And 2 times 0.4 on the right side of that equation is going to give us 0.8. And of course, you can work this out with your Desmos calculator if necessary. All right, so things to look out for. First of all, focus on the operation that is happening to the variable and do the opposite or inverse. Invisible ones in front of variables or parentheses. This is going to be very important when we start doing distributive property, but just know that if there's 1x there, they don't write the 1 that's in front of the x, but it is there. It's an invisible one. Subtracting a negative number is the same as adding a positive number. That's something I didn't cover much in this video, but basically what it's talking about is, did I have a picture? I think I have a picture of it. Yeah. 17 minus negative 3, that's the same as 17 plus 3. So if you ever see a minus and a negative together, you can think of that as addition. Okay, because remember, subtracting a number is the same as adding its opposite. So if I add the opposite of negative 3 to that 17, I'm going to have a positive 3, right? And I think that's it for the things to look out for. So great job, y'all. Remember that to solve equations, we use the inverse or opposite of the operation that is happening to the variable. Remember to cancel out the constant by adding or subtracting. Remember to cancel out the coefficient by multiplying or dividing. And remember to simplify any fraction answers or round any decimal answers if necessary. That did not come up in this video, but it might come up in some of the equations you might solve in the future. Like for instance, if your answer is 2/4, you might want to reduce that down to 1/2. And remember, if you have time, substitute your answer back into the original equation to check and see if you are correct. So that's basically it for one-step equations. The next video in this series is two-step equations. So head on over there and watch that one next, because there's 2 operations to undo on that one. And now it's time for me to say, it was lovely teaching you math today. Bye.